Hi guys, welcome back to my YouTube channel. My name is Dhanush R. I am studying in Sri Venkateshwara College of Engineering, third semester. Our subject is mathematics. We are going to discuss about the engineering mathematics today. In that, the comparison large samples in mathematics. This presentation explores the concept and application of comparing the large samples in mathematics, covering key principles, statistical methods, and the particular considerations. You can see the key methods and the particular statistical methods and the practical consideration. We can see practically how the comparison goes on in the large samples. Importance of sample size. We can see the importance of sample size in three methods, that is accuracy and reliability, and the second one is reduced sampling errors, and the third one is statistical power. Accuracy and reliability. In that, the large samples provide more accurate and reliable estimates of population parameters. When there is a large sample that provides the accurate and reliable estimates of the population parameters. If there is a large sample that provides the accurate result, then reduced sampling errors. We can reduce the sampling errors by increasing the sample size. As the sample size increases, the margin of errors decreases. When we increase the sample size, then that decreases the errors in the margin, leading to more precise inferences. Third one is statistical power. Large samples enhance the power of hypothesis tests, increases likelihood of detecting true differences. By in the large samples, we can empower the enhance the power of hypothesis by increasing and detecting the true differences. Central limit theorem. First one is sample distribution. The distribution of sample means approaches a normal distribution as the sample size increases. When increase in the sample size, then it distribution of a sample also goes to the normal distribution. Second one is mean of the distribution. The mean of the sampling distribution is equal to the population mean. The sampling distribution is equal to the population of the mean of the population. And the third one is standard error. The standard deviation of the sampling distribution with large samples increases with the large sample. The standard deviation of the distribution increases, then the large samples are size is increases. Hypothesis testing for large samples. There are three hypotheses. First one is null hypothesis, second one is alternative hypothesis, and the third one is test static hypothesis. In that, first one is null hypothesis. States that there is no difference between the population parameters and being compared. When there is a when it shows the no difference between the population parameters, where there is no difference between the parameters of the population, that we cannot be compared. Alternative hypothesis states that there is a difference between the population parameters being compared. It shows the different alternative hypothesis shows the difference between the population parameters that we are going to compare. And the third one is test statistics. Value calculated from the sample data to test the hypothesis. This is the value that is calculated from the sample we have taken from, as the population data from the population from the data to test the hypothesis. And confidence intervals for large samples. It is we can see the confidence level, interval width, and certainty. First one is confidence level is 90%. Then the interval goes to the narrow, and the certainty goes to high. Year of error confidence of van. We can see the highest error confidence of the van. So if the confidence level is 95%, then the interval width will be wider and the certainty goes to the moderate. If the confidence level is 99%, the interval width will be widest. It goes to highest level, and certainty comes to the lowest level. Comparing two large sample means. One is t test, the second one is z test. In t test used to compare the means of the two independent groups with large samples. We can compare the mean of the two independent groups. Now, they are not dependent on the samples, but we can also compare two mean of independent groups with a large samples. We can take the large samples as an example, and the samples, and we can compare it is called a t-test. The z-test is used to compare the mean of two large samples when the population standard deviation are known. When we know the population and the large samples of the population and the value of the population, then we can compare them by using the standard deviation are known. And comparing proportions in large scale. Z test proportions. In that, z-test proportion used to compare two population from independent large samples. We can compare the samples in the independent between the two large independent samples. And the second one is confidence interval for proportions. In this, the that provides a range of value that likely contain the true difference between the proportions. It contains the true differences, like if one is at 10%, then the second one will be the 20%. Is the true difference between the proportions. And the third one is chi-square test, used to compare the proportions from multiple groups, assigning if there is a relationship between the categorical variables. That's called a chi-square test. And the practical consideration in large sample comparisons. First one is data collection, second one is data analysis, third one is interpretation. In first, data collection, ensure accurate and represent the sample methods to minimize the bias. We can minimize the bias by using the ensuring the accurate and representative sample methods. Data analysis, choose appropriate statistical methods based on the research question and data type. We can analyze the data by using the statistical method based on the search of questions and the data type. Interpretation, the draw meaningful conclusion based on the statistical findings and consider practical implications. Limitations and assumptions. There are some limitations and assumptions. That is, first one is independence of observation. We can independently observe the analytics, and we can judge them. And the second one is random sample. We can take any sample by in the random form. And the third one is normal distribution of data. We can distribute the data you normally. And homogeneity of variance. We can it is a single type of variance. Conclusion and key takeaways. Comparing large samples provides a valuable insights into population, enabling research to draw meaningful conclusions and make informed decisions. It takes the it takes the large scale samples that can provide the insights into populations, enabling research to draw meaningful conclusions. We can give a meaningful conclusion, and we can take this to the higher level and make informed decisions. We can take decisions very accurately and certain quickly. Thank you for watching.